Welcome back. Let's talk a little bit about density. So density refers to how closely packed the particles are, right? So it's officially defined as a ratio of the amount of mass per amount of volume or space. But another way to think about it is the number of pieces there are in a given amount of space. So here in each of these cubes, I have the same amount of space. Each cube is the same length, width, height. But there's many more pieces in this cube, making this one more dense and this one over here less dense. And density can be calculated then using this equation, which is a ratio of mass to volume, sometimes abbreviated like this. So most common thing we're going to do with density early on is we're going to do some calculations. So whenever we do a calculation, the first thing we want to do is we want to write out that equation, right? So we want to say, okay, density equals the mass over the volume, okay? And then we want to plug in our values. Density is unknown, equals the mass, 12.4 grams, divided by the volume, 11.4 milliliters. Okay, notice how I keep everything linear, easy to keep track of there. Enter into my calculator, 12.4 divided by 11.4. I get my long answer. I can write my long answer first, or I can go right to my answer with three significant figures, which rounded is going to be 1.09, and it's going to have units of grams per milliliter from the units I had up here. Now, you won't always be solving for density, but you can always start the same way. You always start by writing out the equation. This time, right, I got a couple options. I could rearrange the letters first, which sometimes I'll do, but what I'm going to do here is I'm going to plug in, and then I'm going to treat this like an algebra problem. So I'm going to say, okay, 3.4 grams per milliliter equals M is unknown over 3.2 milliliters, my value. And then what I always like to do, this is now an algebra problem. I put this over 1 so that I have two fractions, right? And I can cross multiply and solve for the missing variable. So M times 1 when I cross multiply is M. And 3.4 times 3.2 when I cross multiply is 10.88, and rounded to 2 sig figs would just be 11. So I'd say my mass here is 11, and the unit I'm left with is grams. All right, we can talk a little bit how these units actually cancel with each other. We'll talk more about canceling units a little bit later on. Last example, again, starting the same way, write out the equation. Okay. This time, I'm solving for V. So I could, again, rearrange the letters first, but what I'm going to do here is I'm going to just plug in 12.4 grams per centimeter cubed equals my mass, 8.4 grams, divided by my volume, which is what I don't know. And I'm going to treat this the same way. I'm going to put this over 1. I now have two fractions with a variable, right? Try not to let these other letters throw you up. These other letters are just units. The only missing variable here is the V. So again, I'm going to cross multiply. I'm going to get 12.4 V. Okay, now in these intermediate steps, I don't always show the units. And then 8 equals 8.4 here, but I'm constantly aware of what those units are. In fact, these grams have already canceled. And I'm left with, really, I have per centimeter cubed here. But for the intermediate step, I won't require to show that unit there. But to get this V by itself, then, I divide each side by 12.4. Okay, this cancels. 8.4 divided by 12.4 goes into my calculator. And I get V equals 0.6774, but I want to go to 2 sig figs, so 0.68. And I look back up for my unit, what I was left with was centimeter cubed. Okay, sometimes I box my answer a little hard with this pen, so I'll circle it. And those are a few problems on how to do some density calculation.